Hello, everyone. Welcome to episode 177 of the J Situation Podcast. I'm recording this on September 5th, 2023. Man, it's freaking September. Hope you all had a great Labor Day weekend. Hope you were able to spend some time with your loved ones, cook some great food, drink and be merry, as it were. Yeah, hope you had fun before the inevitable work week started and zapped all the fun away like a black hole. I feel you. I really do. Kind of an interesting time in silencers right now, actually. We have seen some very interesting stuff come to market. And I think we've seen this as the performance desires of users have shifted a little bit in various regimes. So it's kind of interesting. You know, quiet is still king, but the types of quiet that folks are chasing are really being refined, I think. I think that's a good way to say that. So with this episode, I included, I think, a pretty neat photo for you to look at. I placed some silencers in the photo that, to me, all represent a certain part of the rifle silencer evolution. Okay, so some are very primitive, some are relatively new, some of them beg, borrow, and steal technology, and some of them are forging ahead. And it's a really interesting group of silencers, and don't read too much into it. It's just a collection of silencers, but it is a wide variety. So I was messing with some of them. I was like the juxtaposition of some of these I thought would make a neat photo. And actually, speaking of interesting silencers, I think we have a good topic for today's episode. We're going to hit a short tech brief on the PWS BDE 762. Okay, we published a white paper here at Pew Science last week on that. And you know what? This is the first time you folks have seen a modular rifle silencer in the dataset for quite some time. Okay, it's been a minute, so that's kind of cool. So we'll talk about that. And also, what I would like to do after we hit that tech brief is I would like to hit the answers to last week's Pew Science Lab quiz. That's right. That's that recurring segment in which nerds test whether or not you have been listening. They're basically testing whether or not you've been listening to me babble on for the past few years, and if you really read the articles. And that's kind of I say that jokingly. They're really trying to test the knowledge of the general populace and see how folks are thinking about stuff. And I think it's going really well. I think it's pretty fun. So we'll go into that as well. Okay, so on with the show. This episode of the podcast is proudly sponsored by Legion Athletics. That's right. Man, good folks over at Legion. Nothing you do, exercise, sports, really anything is worth doing without consistency. So, you have to do it all the time if you want to be good at it. And I do believe that Legion Athletics can help. They got whey protein, they got pre-workout, post-workout, vitamins, minerals, other supplements. People ask me sometimes, well, do you think they have everything you know that I need, Jay? Can I get everything from there? I say, probably not, but they do have a lot. Okay, so if you visit legionathletics.com, there's a link in the show notes. You can find it there. Use code word PewScience to save 20% off your first order. Okay, and you keep using that code every time you order. You get double loyalty points. You'll end up getting a net 10% off everything you ever order for them going forward using the code. It get strong. It's important. Save some money. Okay, I've started using a lot of their stuff. I'm using their stuff every day now. Whether it's a gut health supplement, or it's a whey protein, or it's a pre-workout, or it's a recovery drink. I really am. I'm using it because I've been putting a lot of the products through the paces to see. Well, for one, is the taste good? Are the ingredients showing efficacy for my use in my recovery or diet? And so far so good. So, and I've been getting a lot of feedback from you folks too. So if and when you do decide to use some of the stuff, I would like to hear your feedback, because if you notice something like that you don't like, let me know too, because I don't know if Legion cares, but I will definitely give them negative feedback, just like I do everybody on everything. unsolicited. This episode of the podcast is also sponsored by Top Gun Range Houston. That's right. If you're in the Houston area, and even if you're just visiting, they're worth checking out. I do think you should check them out. I've been there. It's pretty good. They have a really large 15-lane indoor shooting range, and they have the largest firearm rental fleet in the state of Texas. And you can rent pistols and rifles and shotguns and machine guns. It's pretty good for demoing guns. That's something take it or leave it. I'm a big proponent of demoing guns before you buy, especially handguns. I do think it's important. A gun that you like to shoot, you're gonna practice with it way more. I promise. I promise you will. You can check out their firearm rental inventory on their website at topgunrange.com. You can even find them on Instagram at Top Gun Range. Okay, check them out. This episode is also sponsored by High End Armament Technology, a dealer of exactly that, high-end arms and accessories. Okay, this is a little different than Top Gun. These guys are like, it's a little crazy. They have a significant longevity in the machine gun game, the NFA game, and significant expertise in procurement and operation of night vision and thermal optics, infrared sighting systems. It's a very high-end shop. If you're looking for something incredibly expensive and you want to hear from people who've actually used the gear to tell you if it is actually genuine, if it actually works, and you want to get a good example of such equipment, check them out at highendarms.com, Instagram at highendarms, and they even have a Facebook page, which is also High End Arms. Okay, I hope they can help you if you need it. The episode is also brought to you by Silencer Shop. That's right. You can use their kiosk, do your fingerprints and photos electronically, and in turn, you cut down on errors, you simplify your silencer purchasing process, you get a money-back guarantee. It's pretty good. Sitting on your couch, kind of being lazy, you hit the button there to order a silencer. They have your fingerprints already. Everything's in the system. It's good. It's good for lazy. No transfer fees, no paperwork errors, just you and your silencer with no drama. It truly is silencer ownership simplified. That's right, it is. And finally, and most importantly, for this entire effort, this podcast is brought to you by the Pew Science Laboratory. I am the technical director of the laboratory, and in the interest of public education, the lab sponsors this podcast, and it also runs a public research effort. That's right. And that effort continues to push the silencer industry forward one test at a time. You can visit pewscience.com for the suppression rating. It is the simplest, most accurate hearing safe rating for your suppressed small arms. It's based on true human inner ear response from the entire gunshot, from before the combustion takes place all the way until all the combustion is gone. Pew Science is the home of the Silencer Sound Standard. There are 7 sections. It's the most in-depth and accurate silencer data and analysis in the world, and it's available to the public. Check it out on pewscience.com, okay? The laboratory's worked hard to make that available to all of you, okay? It's 24/7, 365. You can always get it there, okay? And you yourself, you listener, you can support this podcast. You can support the Pew Science Laboratory. You can support all of the public testing that goes on that feeds all of this by joining with a membership at pewscience.com. That's right. You can join the public research effort that the lab does. You can also donate to it if you don't want to join. That's cool too. You can donate, and if you don't want to do that and you don't want to spend any money and times are tight and got to save up for the apocalypse and everything like that, it's fine. You can just give this podcast a good rating on Spotify or iTunes or something like that, just to throw us those five stars to help us spread the word. Maybe we get more members and they help the lab. Maybe we just simply spread the word about suppressed small arms and we start normalizing this stuff. Get a silencer on every gun. One step closer to common use, theoretically. 2 topics for you today. Topic 1, the latest public laboratory white paper. That's right. Sound Signature Review 6.121, the 121st public article, Primary Weapons Systems PWS BDE 762 on 308 bolt action. That's right. We'll do a short tech brief today. This is a modular rifle silencer, so that's kind of interesting to talk about that. Haven't seen modular rifle stuff in a minute, so we'll go into that in the first topic. And then in topic 2, we have another Pew Science lab quiz. Yeah, another one has come and gone. So per feedback, the laboratory did step up the difficulty. Okay, that's the feedback they received. So did you persevere or did you succumb to the pressure? What would you know about pressure? You seen Ace Ventura? Let's go over the answers. It'll be a fun topic, okay? Laces out. Topic 1 at a time of 10 minutes. 16 seconds. 1 second, guys. Okay, I'm back. Have you seen Ace Ventura? The first Ace Ventura? Oh, I recommend that. That is a good movie. I tell you what, topic 1. Yeah, latest public laboratory white paper, Silent Signature Review 6/121. The PWS BDE 762 on 308. Yeah, so we'll go over this briefly, as briefly as we can. There's a lot to talk about here. It's 2 tests in 1. It's interesting, right? A lot of data in this white paper. And gosh, really, a lot of data in August. Wasn't there, though? That month was jam-packed. Jam-packed, I tell you. I think 4 papers. I think we published four papers in a month. How often does that happen? That's wild. No, we put a cap on the month, put a nice end cap on the month with the PWS BDE 762. These folks at PWS have really been doing a lot of interesting silencers. And, that's one of the things I really love about being at Pew Science. We are getting exposed to a large portion of the market in ways that really don't typically happen. We do end up testing things sometimes that are in close proximity to silencers launching to the market. You know what I mean? For product launches. And so sometimes we will, companies approach us way prior to that so that we can test, so it can accompany the launch and they can, satisfy, end users' desires to have third-party laboratory data with the launch. That's one thing that Pew Science has been helping with. And, we're used to doing that. But more often than not, we're actually testing things for folks that are nowhere near marketing cycles or sales cycles or anything like that. A lot of times, it's part of internal evaluations that companies are doing. They're looking to validate what they've discovered with their products with a third party, someone that doesn't have a vested interest in it. So, they'll come to Pew Science and say, hey, we'd like you to test this, and because we're really curious to see what you find, what your findings are. That it's more often than not that is occurring, and so that is kind of the case of PWS here. PWS is a rifle company, and they also make silencers. Okay, so I guess the rifle company first. And I think a lot of you folks might be familiar with their piston ARs that they make. You've seen those, and so the BDE 762 it is a rifle silencer. They're making a lot of different types of silencers, like I said, but this is their 762 rifle model. Okay, it's modular. And it's actually modular in more than 2 pieces. There are actually 4 distal baffles you can use in conjunction with the main baffle section. You got to keep in mind there are a few other silencers Pew Science has tested on 308 bolt action that are modular too, right? You remember we presented data on the rugged Surge, the rugged Radiant. The Silencer Central Banish 30. So those 3 silencers, they have a long configuration and a short configuration, right? Well, so this PWS BDE 762, it also has a long configuration and a short configuration, but because those distal baffles are in a quantity of 4, you actually have 3 more configurations. So you have a total of 5 lengths, right? Yeah, so for efficiency in the test program, we evaluated the longest configuration. So that's with all 4 distal baffles, right? And then we evaluated the shortest configuration, which is with none of those extra baffles. That is just with the first section of the silencer. So we have those 2 tests on the 308 bolt action. So we put those 2 tests in the white paper. That's right. So you can now, if you want, you can compare the longest and the shortest configuration of the silencer to the long and short configurations of the rugged stuff, right? Or the silencer central stuff, right? If you want, right? It's good peg points, good for comparison. So what we'll do, why don't we do this? Go ahead and pull up the article if you like. I have the member review in front of me on pscience.com. It's going to be silencer sound standard SSS 0.6.121. So it's the 121st article in section 6 of the standard. Okay, so section 6, subsection 121 is the PWS BDE 762 and the Savage Model 10 Precision Carbine 308. You can pull up the free review too. It's no problem. The member review just has more information in it. Okay, and so to all of you who are members and you join to support the effort, you are the salt of the earth. I thank you from the bottom of my heart. And you allow this public research effort to continue. Isn't that cool? It's like you're running it, man. You're making it happen, which is pretty awesome. So what we'll do, I have the article in front of me now. I'm sure you do too, unless you're driving or something. So what we'll do, we're gonna hit the high points of the data here. Really, what I want you to, and I do have the silencer in front of me. What I want you to understand, guys, this silencer is basically 3 sections. Okay, you have a blast chamber. It's 3D printed, and it's sort of just like a short tube, but it's 3D printed. You screw a mounting assembly into that of your choice, right? It's got the hub threading, so this one has a direct thread mount that comes with it. You can put that in there. So that's your first section of the silencer. It's the blast chamber, the expansion chamber. Now, next you have the primary silencer baffle stack. It is a single 3D printed piece. That's right. And that screws into the blast chamber. So then you have 2 pieces, right? Well, counting them out, you have 3, but 2 main pieces. Expansion chamber, baffle stack. Now, after that, you have 4 machined baffles and an end cap. So you can screw those into the end of the 3D printed stack if you like, in any number you like, or you can just take the end cap off and put the end cap directly onto the 3D printed stack, and then you have the short configuration of the silencer. Okay, so you have the expansion chamber, 3D printed stack, you put an end cap on, short configuration done. Expansion chamber, 3D printed stack, and all of the baffles that comes with it, you put that on, then you have the long configuration of silencer. Okay, simple enough, right? Just wanted to make sure you understand that, unlike some of these other silencers, there's actually 3 parts to this instead of just, well, three main parts. But when you look at it, you have the expansion chamber, 3D printed stack, that's 2. Then you have 1, 2, 3, 4. Okay, so that's six parts, and the end cap 7. Then you have the mount 8, so really 8 parts. But long and short were tested. So looking at the article, bottom line up front, 48.7 composite suppression rating in the long configuration of this silencer on the 20-inch bolt-action rifle with 308. Okay, so 7.62 NATO. You get 48.7 composite, okay, on a bolt gun hunting rifle. 32.1 at the muzzle, 48.5 at the ear. Not too shabby. It's really not. You go to the short configuration, your composite score drops to 40.4. You don't quite drop a suppression rating category, but you're getting close to it. You get 27.5 at the muzzle and 40 flat at the ear. Scraping by and kept it in that 40 zone. There you go. It is what it is. That's what the numbers came out to. Okay, it's interesting. So that's those are the 2 extremes of performance with the BDE 762 on a bolt gun like this. If you were to add only a couple of baffles instead of all 4 of them, you would get an answer in between the 2 configurations, right? So at the shooter's ear, remember, longest configuration 48.5 at the ear, shortest configuration 40.4. So you have this 8-point suppression rating delta at the shooter's ear, depending on which configuration you use on a hunting rifle with this silencer, right? I'm sure you could think of plenty of reasons why you would want to change that. And I'm sure you can think of plenty of reasons why you would only want to use the short. I'm sure you can think of plenty of reasons why you would only want to use the long, and there might even be some in between. So they give you that flexibility. That's just something you can do. You got to look at the length, the weight, and see what you like as the user, right? It's really your choice. So you got to ask yourself when you look at this data, what is the silencer doing at its two extremes? It's kind of interesting. Because we're just going to talk about that, right? We're only going to talk about the tested configurations, the longest and the shortest. What is it doing at those two extremes? So at the long extreme, at 8.8 inches long with the mount, if you're a shooter using a 308 bolt action, it's sitting in the top 5 shooters ear rankings on pewscience.com, right? It's in the top 5. It's a pretty big deal. It's a pretty big deal, right? I think if you look at the muzzle rankings, I think it's probably in the top 10 on this host. And it's a really competitive group, right? It's a big data set with really high fidelity data and analysis. That's a tough landscape. So right away, that's a significant thing. Just objectively, it's interesting. You're like, huh? Like in that group, that's where it's sitting, and that's something I think folks should look at. Another thing that is significant in its longest configuration is the signatures is fairly unique. When you look at the fingerprints in the white paper, you'll see that it's really drawing out the gas dump for a long duration at a very low amplitude. It's actually very strange. You'll see that during the first shot, the first round pop signature, the first shot when there's still oxygen in the silencer, you'll see it's fairly different. And that's a consequence of the silencer's design. And it is worth mentioning because it is significant FRP. In the member article, the Pew Science members will see that it's a different story for the shooter. Okay? It's not, the FRP does not present the same to the shooter in that configuration. Okay, but again, I just want to. This does bear mention. I want to make sure that you guys understand this. Now, one thing that the PWS silencer does, it executes some early venting in the stack, and this is a DMLS core, guys. Okay, So, and it's something you guys are going to continue to see with manufacturers going forward. Okay, you're going to continue to see folks thinking a little bit outside the box. And it's happening more and more before your very eyes. It really is. So don't sleep on 3D printing. Okay, don't sleep on it. If you're watching technology progression, you'll see that not only is it here to stay, it's going to keep advancing. Okay, it really is. I'm telling you, I've been saying this to you folks. It'll be interesting to see how companies take advantage, right? So, because in the case of PWS with this particular model, they did some things that I think you will see evolve over time. Just stay tuned. I think this is just kind of the beginning of some things that you're seeing folks do. This is, man, you're living in a very interesting time right now in silencers. I say it all the time. People I think are getting tired of me saying it, but you're in a very interesting time in silencers. And I'm not even talking about the market. I'm talking about the technology, because we're on this teetering edge. Now, you continue to look at this data in the article, and the data. I encourage you, please look at the data if you haven't. It's very interesting. After the first round pop, it's a fairly consistent signature. Okay, there are details in the article that you can read, and I do encourage you to do so. But there's something technical in general that I need you to tell you about and make sure you all understand. And I think this is a very good opportunity to have the discussion, and we can actually thank PWS for being an example of this publicly. Okay, I'm not picking on them, but I'm going to use them as an example. Okay, so What do you see when you scroll down in the article and you look at the gas dynamics of the short configuration of the BDE 762? Okay, well, you see a completely different fingerprint, don't you? Okay, so this would be comparing if you looked at figure, for example, you look at figure 1B and 2A, and then you would scroll all the way down and you'd go and look at, like, figure 5B and 6A, you know what I mean? Because we have both test reports, the long and the short. And you look at those two, you look at them and you see something completely different. Particularly the shape of the impulse waveforms, right? So if you look at figure 6, it looks so much different than the ones in figure 2 with the long configuration. And so what did you change, right? What did we change? Why do the plots change like that? Okay, why do they change like that? What's the only thing we changed? Okay, well, we removed the distal baffles. Okay, that's what we did. We removed the distal baffles. So the early time shock reflections inside the barrel and in the blast chamber and the gas propagation in early time through that initial part of the silencer were exactly the same. Right? I mean, that's right. They're the same, exactly the same. But yet, you see the externally measured gas momentum behave completely differently between the two configurations, right? So what's the difference? Gas is being expelled faster, right? You can see that. So what's the difference? Well, omega dropped, right? Back pressure dropped. Agreed? Everyone in the room listening right now, agreed, right? You do expect that back pressure would drop when you remove the distal flow restriction, correct? Everyone, this is by inspection. You can understand this, right? You would be correct if you thought that. So the back pressure dropped when we move from long configuration to short configuration. The back pressure dropped. The omega metric changed. The slope got steeper. Omega metric dropped, right? Right. It's math. It's just math. So, the nuance, what about the influence on weapon function due to shock reflections and early time gas propagation in the first stage of the silencer, though? What about that part? Did back pressure and weapon influence change in that part of the silencer? Like between the two configurations? No. It didn't change because that geometry is constant, right? Geometry is constant. So is there an interaction between the two portions of the silencer? Well, yes. Yes, of course there is, but not to the degree it's grossly changing dynamics up front. Okay? All right, so there's some nuance here, and it gets complicated with timing, and it is really dependent on the silencer's design. Okay, so all this being said, you can do something with this data, right? You can do something. You can do the same thing with this PWS data that you can do with the rugged surge data, the rugged radiant data, the silencer central Banish 30 data. You can install all of these silencers on a semi-auto gun in a long configuration, in their respective long configuration. You can tune your gun, and then you can install the same silencers on the same gun in their respective short configurations and tune your gun. And then you can see not only how the tuning can change, but how the bolt speed and the gassiness out of the ejection port might change. And in some cases, it's not a huge change. Some cases, it's a big change. And in some cases, the signature is insanely different, and in some cases it's not. But the point of all this is you did a controlled experiment, didn't you? You can do that at home yourself. And maybe not in your apartment with 556 or 308. Maybe you go to the range. Don't break the law. No, but that, my friends, this discussion here, that is the omega metric. You see. It's just math. It is just math. It is the rate at which the gas momentum accumulates out of the end cap of the silencer in the free field. Okay? Again, this is important. I know I keep saying this, but it's very important for you to understand. You can't measure this unless you're measuring in the free field. It will not work. Okay? It has to be, you have to measure this in a standardized way. You either have to use the silencer sound standard or the mill standard, which is, and the silencer sound standard test method is the mill standard test method. So you have to use that. You have to be in the free field or it won't work. So you will get an answer as long, and you don't need anything proprietary at all, ever. All you need to do is measure pressure in the free field, 1 meter left of the end cap. And if you do that, you will get an answer. I promise. It's just math. And so for this silencer, you'll get 2 answers, right? So let's look at them. Let's look at the 2 answers you get for the omega metric from the PWS BDE 762. Let's just look at the answer. You have the equations, so let's look at what you do when you plug the numbers into the equation. Scroll down to figure 10. It's all open source. It's all transparent. It's all on the website. It's all here. No, there's no mystery at all. It's literally derived and written down. Scroll down to figure 10. Omega metric on 308. The BDE 762 long is in zone 6 next to the Sandman TI and the Helios QD. Okay. The BDE 762 in the short configuration is in zone 4 next to the SOCOM 762 RC2 and the Trash Panda. Okay. So omega metric dropped when you took the baffles off the silencer. That should track with logic, right? Cool. You're all with me. Makes sense. Gas gets out faster, omega metric drops. Done. Awesome. Now, if a silencer has a similar omega metric to another silencer, does that mean the back pressure is similar? The answer is maybe. The answer is maybe. That's right. What you thought I was going to say yes? It's like, well, no. The answer is maybe. And there's more nuance to this, and sometimes things have nuance. Remember when you're in school and they're like, neglecting air resistance, what does the airplane do? It's like, what? No, you can't neglect certain things. So the answer is, so let me repeat that. If a silencer has a similar omega metric to another silencer, does that mean the back pressure is similar? And the answer is maybe. Okay. The omega metric is a research parameter, is a calculation. And if you really understand what it does, and if you've been following along with the research, and if you read the articles, you will know that there are some things about gas flow rate from a silencer you can't measure externally. You just can't. Take the Trash Panda. It's right next to the BDE 762 short on this plot, so it's a really great example to pick. Take the Trash Panda as an example. What mount does a Trash Panda use? I'm not talking about some third-party mount. I'm talking about what comes with it. What is intended? How is it tested? What mount does the Trash Panda use? It uses Cherry Bomb from Q, right? It uses Cherry Bomb. Okay. That silencer has a similar omega metric on this host as the BDE 762 short with its direct thread mount. Okay. You can see that. Which silencer do you think can make a gun overfunction more prevalently? The Trash Panda or the BDE 762 short? Which one? Well, I'm going to guess the Trash Panda. Why? Why do I guess that? Well, it uses a Cherry Bomb, and the Cherry Bomb is a known shock reflector and flow altering device. We've done field experiments. The public has. It's relatively well known that the Cherry Bomb affects early time gas dynamics near the uncorking event. The uncorking event defined as the projectile leaves the muzzle crown and the first jetting occurs. Now, does that mean that the Cherry Bomb is a bad muzzle device? Absolutely not. Absolutely not. No, it does not mean that. Does the Cherry Bomb do some good things? Absolutely it does. It does some great things. The cherry bomb does some great things. Is it the best choice for all systems? No. No, it's not. Okay? So you see, folks, you need to understand what parameters on the website in these white papers are to be used directly and which are to be used with caution. Okay? We do not put the omega metric in the rankings chart. Understand? You can't do that. You are not ranking using the omega metric. It can't be used like that. Use it in the research to understand external gas dynamics. And when the silencers behave similarly up front, that means, in their geometry up front, use it intelligently, guys. Use it, but don't use it as a perfect one for one, like a universal back pressure metric. It's not that. It's not that. That's not what it does. Okay. So now here's again. I'm taking you down this road slowly. I'm building to it, but here's something that might shock you. You guys know why it works so well most of the time, right? You guys know why the omega metric works most of the time pretty good, right? You're not going to like this answer, but I'm going to tell you why. I'm going to tell you why the omega metric, the simplified parameter, works most of the time. It's because most silencers are copies of one another, of copies of one another. He said something mean. No, it's like very few silencers have any real innovation inside them at all. That is reality. And some of the very popular high-ranking silencers in suppression on various hosts on the website are extremely primitive. Okay? We have said this for years, guys. We figured out how to make silencers quiet a very long time ago. Okay? Making a silencer quiet, guys, it can be done. Okay? How they are being made quiet is the challenge that innovators are tackling right now. I don't know if you've started to notice that. You can notice it by looking at the waveforms and the signatures. When you start to see, you understand. So, excuse me. So the question is, can you make silencers quiet and also flow favorably for weapons and the operator and hide flash and not break and not be huge and not be heavy and not be long? Right? It's a different sport, right? When you start to optimize, right? So the reason the omega metric works so well is because so many silencers that are the same thing. They behave so similar in the early time, like the whole front half of the blast chamber is the same damn thing. So I think what you see, kind of to get this back to PWS here, I think what you're seeing here from PWS is a bridge. I think what you're seeing is a bridge. I think you're seeing bridging in technology. Folks have 1 foot in the past and 1 foot on the doorstep of the future, and one of their feet's in a doorway. And beyond the doorway is a portal, and that portal has weird trees and life forms and stuff in it that represent a whole new world of silencers. But who is going to enter that portal? Who is going to enter that portal, fall down, skin their knee, dust themselves off, get up, keep hunting the weird alien animals that have antennas grown out of their heads that kind of look like Dr. Seuss characters, but maybe they spit poison out of their scent glands. I don't know. Maybe we get more hunters every day. Maybe more people are going through that portal every day to go hunting. Maybe, maybe more companies every day are looking to exploit alien thoughts, strange alien thoughts. What are alien thoughts when I say alien thoughts? Thoughts and implementations in design that are alien to the status quo. Okay? Think about it, man. We test a lot of silencers here at Pew Science. We see them all. Okay? And I'm telling you, most are not alien thought experiments at all, guys. They're cookie cutter. I'm sorry. Okay, and that's sometimes we have to call a spade, and we have to say things like this. You have to think about that, and that's why we have parameters like the omega metric, because it's so simple. Because silencers are so simple. The more complicated silencers get, the more simplified parameters don't apply like that. Okay, that's just how it is. So when I thank people all the time on this podcast, today will be no different. I'm going to say thank you to PWS. What are they doing? Well, they're venturing off. They're venturing off with bravery into a land unknown, aren't they? They're just started. They're dipping their toes in. What else can you do? What else can folks do with 3D printing after testing the waters? Well, you got to walk before you run, don't you? You got to walk before you run. So what else can folks do with 3D printing after they test those waters? I think we're going to see. I think 3D printing, machining, welding, it's not about the technology, guys. It's about what you do with it. Those are just manufacturing technologies. When you're a kid and you want to make a Christmas ornament out of construction paper with scissors, are you really obsessed with the type of scissors? What are you doing with those scissors? Does your ornament look cool, or is it just the same as all the other kids' ornaments? I don't know how many analogies I can pull out of my butt here, but you know what I mean, Jelly Bean? Who is willing to risk it all? Who is willing to risk it all? We'll see. So big ups PWS for trusting our lab to characterize your systems. You'll see more. You'll see more from PWS. Now, so final thoughts on the BDE 762. I'd say you probably agree with me. You probably don't have as much flexibility with most rifle silencers that you do with this one. In particular, I think you'll probably be hard-pressed to see many modular silencers that can span a performance gamut like this in the way it does. I think the fact that the short configuration is hitting 40 at the ear is a big deal. It's likely that most people probably don't go hunting with a typical 308 bolt gun without a silencer that's hitting maybe upper 30s, lower 40s at least at the shooter's ear now. Nowadays, to 2023, right, without hearing protection, right? And why do I say that? Well, that's where we're sitting in the market. If you look at the ranking section on pewscience.com, pewscience.com/rankings, or if you're a member, look at the members ranking section. Look at it, man. No, I'm saying if you're a member, go to the member ranking section, scroll down past that table, use the data visualization tool. With the links and the weights in there, the filter, it'll help you guys. Look at it graphically. Forget about the composite rating if you're a member. Use the power of the muzzle and ear in data space in section 7.2 of the standard. Look at that. It'll put things in perspective for you, I think. I don't know. I really do think that visualization tool for members, that one thing it does help you with is it ignores the composite rating. It just has the muzzle and ear charted as the two dimensions of the plot. I think it helps. I think it puts it in perspective. I think removing the composite rating someday might be a good idea. I don't know that you need it. Then again, it does a job, as we've talked about before. It does a job for a certain demographic. So that's all I got on this one, guys. We'll see. Muzzle and ear are king. And I think you got a lot of, remember, look at the suppression rating graphic at the top of the page with this one. You get the muzzle and ear for both configurations. That's a big, you could try to interpolate for remove some of the baffles, see what you find that you get. But it's a good bounding case, I say. Okay. Let's move into topic 2. At a time of 43 minutes. I just skipped over that. At a time of 44 minutes and 6 seconds. Okay. Topic 2. Another Pew Lab quiz has come and gone. That's true. It has. So per the feedback, those folks, they stepped up the difficulty of the quiz just as a trial at this past week. And so did you guys get it right? Or did you freak out? No, I would say this was actually a difficult quiz. It was difficult. I looked at it. I was like, oh, wow, okay. We'll see. I had faith in you, but it was difficult. Some of you thought it was easy and you got it right. For those of you who didn't overthink it, you got it right. for those of you who think way too much, which is never a bad thing, but some of you who really lost your, I don't know, some of you who like thought really, really hard, you might have thought a little too hard, and you found that there probably might have been two acceptable answers almost, right? Because the question was, wave momentum transfer is quantified by measuring blank. And there were four choices: pressure, decibels, impulse, and duration. Okay. It's all in the wording of the question. They use the term measuring. They say wave momentum transfer is quantified by measuring blank, and it's interesting to see where people's minds went. And I do look at this and think to myself, maybe it was a bad quiz design and I'll explain. So the definition of impulse, momentum transfer potential, it will point you toward the correct answer on paper, which is C, impulse. Okay, the answer is C. Wave momentum transfer is quantified by measuring impulse. That's the answer. We use impulse to understand wave momentum transfer. That's it. It is the physically correct quantity. But what do we measure? Right? Well, we're measuring pressure, right? We're calculating the impulse. We measure the pressure, we calculate the impulse from the measured pressure. And that, my friends, is why this is one of the reasons why the quiz is incredibly difficult, because in fact, each of these answers can be correct. Actually, all of them. All four of them might even be correct if you do mental gymnastics, right? But here's something maybe this is going to give you flashbacks or PTSD or not, but like with all quizzes, the best answer needs to be selected. Okay, so remember when you were in school, the instructions would state, select the best answer. There's a reason they said that. Because sometimes multiple answers can be right, but there is a best. So the question was, wave momentum transfer is quantified by measuring blank. 36% of you answered A, pressure. 36% of you. You got it wrong. But it could be that you were correct that we measured that, but I doubt it. I think you just got it wrong because you didn't know what you're talking about. I think that's probably true, and that's not an insult to you. But I think the majority of you who got it wrong and picked 36% of you, I think you just got it wrong, and that's okay. 10% of you said decibels. Now, the reason that's wrong is because we don't measure decibels. That's a logarithmic unit. It's not a physical quantity. We measure pressure. We don't measure decibels. So you can never measure a decibel. Doesn't make sense. That's like you saying, "Hey, how did you measure the distance between those two trees?" Or what did you measure to quantify the distance between those two trees? And you said, "Oh, I measured meters." No. You measured distance. And your measurement had a unit of meters. Okay, you measured a distance. You don't measure meters. You measure a distance, and then you can say the distance in meters or feet or furlong or whatever. Answer C, 42% success. 36% A, wrong. 10% picked B, wrong. C, 42% of you picked impulse, which was correct. That's the correct measure. That's the correct measure of gas momentum transfer potential. Okay. 13% selected D for duration. Now, if you selected D, the 13% of you who selected D, that's actually more correct than decibels is. So if you got it wrong and picked D, you weren't as wrong as the people who picked B, right? So in order, let's say that. Let's give you a mulligan. In order of answers that are acceptable from best to worst, it would be impulse is the best answer. Duration would be the second best answer. Pressure would be the third best answer, and then decibels would be the last best, the worst answer. Right? So the majority of you got it right, 42%, but barely. F plus, no, barely got it right. So I think what we'll do, guys, is we'll keep the difficulty at this level or below this level for now. I told the guys, I said, hey, I think we reached the threshold for the masses. Let's build it from here. Relax. They're not going to be going harder for than this for now. I think what they need to do, in my opinion, they're going to do whatever they do. But I think getting the critical thinking juices flowing a little bit is good. Because remember, guys, I look at this. I looked at this answer set here, and I see, wave momentum transfer. It's like, oh my God, who even knew that? And then when you see 42% of you say impulse, it's like, well, thank goodness. There's a time component to this. So you're thinking about duration, you're thinking about momentum, and it's not just like the simplified time metrics like a lot of people think about. They look at these like time weighted averages of pressure and like these OSHA regulations for a second. No. There's multiple impulse peaks in the waveforms that you see at pewscience.com. There's multiple things going on, especially the shooter's ear. There's multiple pulses happening, especially when you have semi-automatic weapons. You have multiple pulses that are exceedingly complex. You can't possibly use old methodology for dosing that you would use for like a simple waveform for a simple shock of like an unsuppressed gun or something. No. These are suppressed small arms are highly complex. So when you guys are getting a feel for that, and when you're looking at these quantities, and most of you are picking impulse, that shows that not only you're reading the articles, but you're thinking. And so even the 13% of people saying duration means they're thinking. They're thinking. That's good. That critical thinking, I think, is something we need to improve and build. And that's what I told the guys, and I think they agree. Okay, so I'm really proud of you guys, all of you, guys and girls. I'm proud of all of you. You guys continue to surprise me, and I think the Pew Science family. Us on this side of it, we're in awe of everybody. The feedback I get internally here at Pew Science is that, you know what I'm told? You know what they say to me? They say it is amazing what the consumers are capable of. And that is just, it gives me chills, It's amazing. We have people not only participating in these quizzes, but doing extremely well. Very high level evaluation of physics knowledge. We have thousands of people who know what's going on. They're getting better every day. It's amazing. Okay. It's so cool. So yeah, it's Pew Science Army, baby. That's what it is. All right. Out there, aggressive. All right. That's all I got for you today. I hope you enjoyed today's episode. I think you guys did great. I hope you learned something about the BDE 762. Go check it out. Go check out the article if you haven't. Tell your friends. Go join Pew Science. Join the Army. Learn shock physics. Shoot guns. Be a ninja. Stay safe out there, friends. I'll talk with you folks again soon. All right, bye.